Go ahead and start presenting, and we'll take the balance of the time.
All right, let's do this. Okay, so I have a, for those of you who want to like play around with TypeScript a bit, because I think that's the best way to learn. I've got a, it's also, this repo I created, it's also in the meetup event info somewhere, but I put it in here too. So this is what I'm going to be basing today off of. I'm going to be using it a little bit. It's just a little environment that I set up for writing and testing TypeScript. So this will kind of be it's just a fun little playground area. So feel free to clone it down and use it for your own purposes. That's what it's for. So, but before I go any further, I'm curious to know, so I already know Terry's situation, but I'm wondering for the rest of you, what are you hoping to get out of today? Like, do you have TypeScript, any prior TypeScript knowledge whatsoever? Do you, kind of where are you guys at with TypeScript?
I've used it a little bit and maintained some Angular projects, but never written it from scratch myself, so I'm trying to go deeper.
Okay. Anybody else want to volunteer? Oh, I think you're muted.
Yeah, still not hearing anything.
Oh, yeah, you're still muted.
Can you hear me now?
There you go.
Yeah.
I'm sorry, I had a microphone plugged in. It was off.
It's all good.
Hey Ben, thanks for the meeting. I want to use TypeScript. I hate the ugly syntax, how it makes your code like all these brackets and stuff. I know that sounds lame, but I've been coding JavaScript a while, and it's like everybody's moving to TypeScript. If you can convince me to use TypeScript tonight, that would be a blessing. Like I don't want to learn it, but I know JavaScript really well. And I think it's useful, and I know it's a good tool. I need to see you use it.
Yeah, you got to get over the syntax. No, I had the same. So I had the exact same kind of skepticism where I was like, I know JavaScript well enough. Like I felt fluent enough in it that TypeScript seemed to have not as like the cost seemed too high for what I thought it gave me, and so I was definitely skeptical of it. But as I've been kind of forced to use it in various employed positions, I've actually come to really appreciate it, and now I rarely go back to vanilla JavaScript. So I'll try to convince you that it's actually pretty great. But I empathize with you 100%. I know where you're coming from. Abby, you don't. If you'd like to volunteer, you're welcome to. If not, we can get right into it. It's up to you.
I've never worked with TypeScript at all, but I'm really excited.
Okay, cool. And are you familiar with JavaScript?
Yeah, definitely.
Cool. Great, cool. So that's kind of so for this, I'm just going to assume a basic knowledge in JavaScript. That's really all that is necessary for this. So let's get right into it. So I'm going to share my screen. Okay, can everybody see this? Cool. All right, so this is the first place that I tell people to go. Obviously, the documentation. I'm only going to just point out a couple of things. So once we're done with this, what I would highly recommend is for all of you is to check out these links right here. If you're not a Java or a C# or don't have any like strongly typed language background, then this may or may not be helpful to Java C#. But but there is absolutely a lot of good information in here, more than I could possibly hope to go over in an hour. So the handbook is very, very helpful. So this is the first resource that I tell people to go to. Their documentation is phenomenal.
And I'm going to get all the links written down and send them out too, so don't worry about trying to keep up with them. I'll post those as well.
Sweet. All right, so the first thing I'm going to do before I get into my little repo I created, we're going to start with the little playground and just talk about some very basic concepts. So TypeScript is a superset of JavaScript. And all that means is that in math, a superset or a set is a collection of things. A superset is simply a collection of things of which some smaller set is also included in that. So when we say that TypeScript is a superset of JavaScript, what we just mean is that any JavaScript syntax is also valid TypeScript syntax. But there is also additional syntax that TypeScript provides as well. So the second important thing, in addition to it being a type language, is that it is a compile time type checker. So it's very similar to like C++ or C# or any of those, or any of those family of languages where values are checked prior to the program being run. So that just means that you've got a parser or a compiler that's checking your syntax, making sure it's good, and making sure that whatever values you are using and defining are being used appropriately. So what TypeScript basically lets you do is define what types your values may or may not have. And it's a really powerful tool. And while, yes, it does cause your code to be bigger, it's definitely fatter, the efficiency that you gain from it is pretty impressive, I gotta say. Especially when you're working in giant applications where, you know, even one tiny stray undefined or null can like break everything, and it can be very, very difficult to track that down. So TypeScript can solve a lot of problems beforehand. So that's what TypeScript is. And one very important component of TypeScript is the way that it decides what is a type. So TypeScript uses what's called structural typing. Structural simply means that a type is defined by its shape. So, for example, if I have a variable called a person, it has a name, that this type right here can be deduced based on its structure. We know that it's an object, and we know that it has a property called name, and we know that that name belongs to the type string. So if I define a type called person, so we can say, so we're going to talk about some of the syntax here, but just as a kind of bird's eye view of what's going on here, I can define a person as an object, as a name, which is a string. Okay, and I'm going to write a function that says print name. We're going to put in the person object, and we're going to say objects.name. All right. So you're going to notice a couple of things here. Got a so far, aside from this little thing, which I'm going to talk about in a second, this doesn't look any different than normal JavaScript. And in fact, it isn't. This is pure JavaScript, good old-fashioned JavaScript. Great. And our error is telling us that this object implicitly has an any type. And TypeScript usually doesn't really like that. The reason why is because of how lenient JavaScript is in how you define things, especially parameters to functions. This is simply not very helpful from a typed perspective. Saying, or when you just put in some variable like that, I don't know what that is. We know that it is something, but we can use TypeScript to be a lot more particular. So in this case, I'm going to say, hey, you are a person. And my function, whose job it is to simply print a name, notice there's no return value in this function. If there were, I would define the type of that return value. However, because I'm not doing a return value, I'm simply going to say void, meaning this returns undefined. Okay, so now what we're going to do is we're going to call this function. And I want to point out something very important with how TypeScript defines what a type is. So what I want to point out is the fact that this is doing fine. It works great. I'm not even getting any compile time errors. And this is because TypeScript is a structurally typed language. Notice I didn't actually explicitly say that person was a person type. Okay, had I done this, or suppose I do something bad where I define this name as a number, look what happens. Argument of type name number is not assignable to parameter of type person. So this is breaking because, well, the shape of this object, the structure of it is, to use TypeScript lingo, what we've done is we've tried to pass in something that doesn't match with the type that's being expected by this function. This function is expecting a person object. Well, this person object doesn't match that shape. If it does, say I put this back to this, well, now it matches the shape perfectly, right? I have a person who has a name that's a string. So now the compiler doesn't have any problems with that. But what we can do to make this even, to enforce this even better is notice how my person object, I didn't actually define its type. Its type is being implicitly inferred based on what its values are. And sometimes it's fine. But usually it's beneficial to kind of anticipate your types ahead of time. So in this one, we're going to say you're a person. And what this allows us to do is when I define an object, it's not going to let me even define that as a number. This has to be a string. We're going to get this error, which you will become very familiar with as you learn TypeScript. You're going to see this error all the time. Type number is not assignable to type string. Oh, well, that tells me that needs to be a string. Does anybody have any questions so far? All right. Cool. So this is kind of the first, I guess, footstep into TypeScript. This idea of defining a type, defining a variable that belongs to that type, and then implementing it in, say, a function, or perhaps some other if statement or for loop or something. But this is classic Classic TypeScript right here. So with that in mind, let's go back to some of the very basic types that TypeScript uses and contains, and kind of how you'll see them being used. So get rid of that guy. So in TypeScript, just like it is in JavaScript, there are basic types. So you've got string, number, Boolean, symbol, which we won't talk about today, and function, and array, and object. I think that's everything. Oh, and undefined and null, of course. So yeah. Array, and you've got object, and you've got, and then in TypeScript there's void, etc. So these are your basic types. Oh, and then function, which is actually denoted as. So here's kind of your some basic types. Now, when you're defining a variable, comment that out. When you're defining a variable, you can, depending on what it is, you may or may not need to explicitly type it. So let's say I have X. Let's say you're 10. Okay, now in other languages, it would actually be necessary to specify that this is a number. However, TypeScript is a little lenient in this case, and in fact, it will automatically infer the types based on literals. So if it's a 10, this becomes a little redundant. It's not actually necessary, especially given the fact that this is a constant. If I did let x equals 10, or let's use a different variable name, y equals 10, then because it's a let, which means that y has the possibility of being reassigned, you would want to define that as a number. Because I could, if this were normal JavaScript, there's nothing really preventing me from doing something like this. Right? Y is now, look at that, type string is not assignable to number. Well, if I say that you're a number or a string, well, now there's no problem. If I say you're a number, well, then it's not going to let me reassign that to a 10, at least a string 10. So now this would also be the case for Booleans, for strings, for Boolean strings and numbers. Things get a little more interesting with arrays and interfaces, which we'll talk about a little bit later. So I want to give people an opportunity to ask questions too. So is anyone good up to this point? Beautiful. Okay, so the most common, I guess, thing in TypeScript, or one of the most common problems you're going to run into is defining the shape or the type of functions. This is important because JavaScript is just so functional. So suppose I have a function called sum. Well, it's a function that takes x and y, and it's going to return x plus y. Okay, now you're going to notice that we're going to see some errors here. Parameter x explicitly has an any type, and y has an any type. So we don't want this. We want to be able to specifically say what this is. So in our case, we're going to say that x is a number. So this is how you define types on a function, on function parameters. It's just with the colon syntax. So if we know that x is a number and y is a number, then x plus y gives us exactly what we want. And we also want to say that this function returns a number, although it is also implied by the fact that two numbers that are being operated on by the plus sign will, of course, be a number as well. But I like to be explicit about my types, so that way there's no confusion. Okay, so here's my sum function. So now when I call it with 10 and 12, I'm going to get I can now see that Z is a number. I could, of course, do this. But again, it's a little redundant given the fact that I already know that that returns a number. But these are just some things that you'll kind of become aware of as you practice more. Because TypeScript is actually very good at using inference to derive types. But it really depends on how you set your situation up. Because one of the things that I've found, and this actually kind of comes to your point earlier, Paul, about having to write double the amount of code. What I've found is that you actually don't have to double the amount of code you write. It's usually only about 25% instead of 100%. Because if you type things effectively and efficiently, then you end up being able to infer types very easily. So you don't have to like write numbers and types all over the place. You can kind of have a few select types that are determined ahead of time, and then everything else can kind of be deduced from those types, and the compiler will be happy. All right, so here's our sum. Let's just make sure that this works. Let's make sure it runs. There it is, sweet. That's exciting. Okay, so let's talk about, now that these are, so we've talked about numbers, we've talked about strings. Strings and Booleans, of course, are very similar. Works the exact way that you would expect. So just for an example, let's say I want to know whether X is larger than Y. I can say, hey, this function is going to return a Boolean, which of course is true or false. So let's console log is larger than, is 12 bigger than 10? Yes, it is. Boom, true. So those are your basic types. Undefined null, same thing, works identical. So I want to get into some more slightly more interesting things, such as the arrays and objects or interfaces. So when we're defining arrays, it's important to define them in terms of what they contain, which is probably pretty obvious because that's kind of the defining characteristic of an array is what does it contain. So the syntax for defining what an array is very intuitive. So let's call this array numbers. Now, when you define an array like this, notice it's going to default to its the widest possible type it could be. So because we've defined this as an array, we at least know that TypeScript can at least deduce at compile time that this is an array. However, there's no way to know what kind of values may be in there. That's why it says any. So like at this point, I could do that, and it's not really gonna, it doesn't know what I want. It says I can push in anything. So I could put in the letter X. I could put in the number 10. I could put in the value true. This is not that helpful because most of the time your arrays, if you're using arrays properly, you want to show what it has, or you want to enforce a particular category that those values should be in. So the syntax is to say array, and then whatever the thing that you're containing. So in this case, it's a number. So now, if I try to push anything that's not a number, such as an X, not going to work. Can't push a string into an array of numbers. That's very helpful. There's, of course, you can widen this as much as you want. Suppose I care about having numbers or strings. Well, then I can do this, and now it'll let me do stuff like I could push in the letter 10 or the word 10 or the number 10, and that'll be just fine. So we have some leniency there. So arrays, I think, are pretty straightforward. Objects become slightly more complicated only because objects, by their nature, are more complicated data structures, but I'm going to take a look. So the most basic way of defining an object is through an interface. So an interface is just, and I used it earlier, an interface is simply a type that you can give a name to, which defines what the type of properties it has. So we're defining the shape of something. So the syntax is very straightforward. It's just interface followed by the name of the interface you want to give it. So let's call this user. And then now we can define the properties just like we would anything else. And inside of here, we can, all the rules of TypeScript apply. I can say friends, which is an array of users. I can say, ID, which is maybe a number or a string, whatever it may be. And then maybe an email, which is a string. And then maybe admin, which is a Boolean. This is how you define the shape of objects. So when I go to define an actual object, let's call it the root user. We can say, hey, you're a user. And what's nice about this is that TypeScript is going to yell at me until this value matches that shape. Okay, so notice I just have an empty object here. So it's telling me what properties I'm missing. This is amazing. I took this for granted a lot when I was doing normal JavaScript, but the idea that my objects are so much more explicitly defined is a huge time saver. So in order to fill this out, I'd have to, I could continue here. There are some cool things you can do here. You can make things optional. So for example, if I don't want email to necessarily be a part of the user, but it could be if you want, go ahead and put a question mark. That'll let you define a user with or without an email property. That's helpful. We can extend and combine things in TypeScript. So, for example, I could define a special kind of user that, let's call this a, trying to think of a, let's do a, I don't know, member, whatever, it's arbitrary. So perhaps our member is a user, but also has an account number. They've created an account or something. So these guys have an account. Okay, so, well, my member, I've got 2 options. I can either extend the user So if for those of you who are used to more class-based inheritance, this will be intuitive to you. So now if I define my root user as a member, it will now require me not only to have all the properties that user has, but it will also require that I have the account number. Also very useful. But there's another way we can do this too. So for those of you who are more used to functional programming and composition, sometimes interfaces are a little too rigid. And extending things via inheritance sometimes may not be the most intuitive way to represent your data. This happens. So that's where type aliases really come in handy. So instead of using the keyword interface, I'm going to use the keyword type, and this lets us define a type alias. Okay, so that just means that it's a type with a custom name. That's all it means. There's nothing crazy or magical about this type word. It does have there are some subtleties as far as how it differs from interface, but it's not very magical. What we're going to do in this case is we're going to say, hey, member, you are the combination of user and whatever properties I want the member to have. So instead of extending it, because now we're using composition, so we're not extending anything. There's no concept of extending something in functional programming paradigms. We're just going to say, hey, member, you are equal to a user combined with this shape. And I could just as easily define that shape with another type of alias or with an interface. I could say interface member properties. Then I could say, hey, you have this. And then and then I can simply replace this shape here with member properties. And that gives us the same idea. And this would now become user member properties. Yep. So obviously we would still need to complete the rest of this. So I would have to say, okay, there's an account number, 1, 2, 3, 4, 5. That's my bank account, so no one use that, please. Friends, obviously. Maybe this person doesn't have any friends. I'm too lazy to write that out. And then we've got an ID, let's say it's indexed. And then we'll have an admin. This person's admin will say, and there you go. There is our, there's one more. What am I missing? Oh, email. Oops. All right, no more errors. Everything's good, no errors. So there's my root user. Maybe I could change that to member, so it makes a little more sense. All right, so those are kind of the basic building blocks that TypeScript gives you. You've got your basic types here. You can define arrays. You can define objects, which are usually interfaces. You can also use type aliases. There's a lot more you can do with type aliases, which if there's time, I'll get into that. And then, yeah, and then we have the union operator, which is this guy, which lets you combine types. And then we have the or, which I used earlier, which is the single bar, which lets you define either or. So it's also called it's actually an inclusive or. That's an important little detail. So yeah, so before I go to my actual code repo to show you some examples of this being used in the wild, does anybody have any questions?
I want to ask one in case you don't go into it later.
Yeah.
I don't want to get into a JavaScript war, but I use a React, and they have prop type checking and flow and all this other stuff. So I guess I just don't know. The people that are really using TypeScript, do they now not need those other type checking tools?
Yeah, this makes prop types redundant and obsolete.
Okay, thanks.
Yeah, in fact, it's way better than prop types, because not only do prop types only let you type check the properties that a component can have, it's not doing any compile time checking. So it's not actually, you don't get the benefits of a compile time checker the way that you do with TypeScript. Plus, you only get the benefit of typing props. Well, what if you want to type check other things? Like you have some like third-party library that you want to know what the types are, or you're building your own little library or something that you'll be using in React. Like you want to be able to type that stuff too. Prop types is very, very specific. So TypeScript basically lets you do that in an even stronger way. So yeah, that's a great question. All right. Cool. Anyone else before I go into the Cody thing?
I'm wondering more about types, but that's probably a little later on.
No, go ahead.
Is that basically the same as a class at that point? What is the difference between a class and a type? I get interfaces.
Okay, that's a really good question. So let's talk about that. So you'll notice that I used two different ways of defining an object. I use type. So, type person equals this thing, right? But I could also do an interface. We'll call this other person, just without some name collisions. Okay, so these effectively are very, very similar. There are some subtleties that I will not get a chance to talk about explicitly right now, but I will point you to in the documentation where they go over that. So in the interfaces section, there's a lot of really great info. There's a specific let's see here. Which one was it? I believe it was in here. No, it wasn't here. So if you look at class types, so this is a good place to look to see how classes relate to interfaces. A class is very similar to an interface. Obviously, a class can have like methods, but you can also define functions on an interface because it's just a description of an object, and objects can have methods, of course. But the main difference between these are that a class, when I define a class, let's say a person, which that's not going to let me do that because it's already defined. So this is now a runtime constructor function, whereas an interface, if I were to find other person, this is not compiled into anything. This is a simple type. So a class is an actual constructor function, whereas an interface, until you actually define an object, that is a person. Like this is specifically only for type checking. That's all an interface does, is it just lets you define the shape of an object and enforce that shape. Whereas a class is doing that as well, but it's also like it's a full-on function, right? Because that's what classes are. Even in ES6, when you use a class in ES6, you get a full-on constructor function from it, and that's what you get in TypeScript as well. But it allows you also to do stuff like, are you an instance of a person? You know, stuff like that. It lets you ask certain questions, which is kind of cool. So, but then this type alias, this type keyword is a little more subtle, because it's very much an all-purpose thing. It's kind of like var in JavaScript, where you can simply construct a type using any of the types that TypeScript gives you. You can construct one and then give it a name. That's why it's called type aliasing, because you're giving a type a particular name. So does that help answer your question? Do you have any other?
I think so. I'll have to go play around with it, but that helps.
Yeah, yeah, and like there are some subtleties as far as like how like this is different from like the person interface. For example, like if I wanted to, so in fact, this is a let's say I have a again, I'll use that user example, and in this case, we'll just have a username just to simplify. Okay, so I've got a user. Okay, now suppose I want to be able to define various types that are essentially the same thing, just with an added ID property, as if like we had just gotten it back from a database. So, but I don't want to conflate the two, because on the front end, I may be using this entity before it actually gets turned into a database object. So there could be some properties that are missing from this, which are still useful on the front end, like for forms and things. So it might be helpful then to have a property or a type that has all the properties of this, just with some additional ones. Okay, so perhaps I want to, like, in my naive state, I might think like, oh, well, I'm just going to define an interface that is called a DB user, for database user. And I want it to be everything that's in the user, key of user. And there we go. Okay, it's and then I want to be able to say along with an ID, which is a string. You know, that would be nice, but unfortunately, that doesn't really work. If we use a type, however, it does.
You got my hopes up there.
Say what?
You got my hopes up. That looked really useful.
So we can't do that with the user, but we can do that with a type. We can do this. We can do a very similar thing. So what I'm going to do, it just looks a little different. So what we're going to do is we're going to say, okay, all right, DB user, you are an object that has everything in user. And what did I do wrong? Key in. Oh crap! I'm like totally spacing what the syntax is for this. I use this all the time. Key of. I'm doing. Oh duh! It's just K in. My bad. K in Kiev. There we go. Okay, that's what I meant to do. All right. Syntax for that is just, here's a property K, which we're defining here. And we're saying, hey, property K is anything that's in a key of user, meaning the set of keys that user has, and then the value associated with that. And we're going to say that DB user is this object, which is essentially a copy. And it might be tempting to do something like this, which you cannot do. But what you can do is just use a union type. Like that. And there you go. There's your DB user. So now when I define a user, it now has a username, but then it also has an ID property. Make sense?
Yeah, I didn't know you could do that.
Yeah, it's pretty awesome. Now, this is a little overkill for this example because this is essentially the same as just saying user and. But I wanted to illustrate that you can do that because the thing is suppose we have a situation where, okay, well, I want to use some shape as my base. Maybe base isn't the right word because I don't want to imply that it's a base class necessarily. But let's say that I have an object that has properties, perhaps like a configuration object. So let's say that I'm writing some function that requires some, I don't know, some configuration. Okay, so I'm going to define here's my base config. So this is the thing. These are like your defaults, let's say. Okay, so maybe it has a name. Maybe it has a, I don't know, should do something. That's a Boolean. I don't know, I'm trying to think of some other random configuration jargon. It's how update after thing. This is a good one. And then let's do how many things. I'll do a number. Okay, so here's my arbitrary config for some random thing. Now, usually when you have a function that takes a configuration object, you don't necessarily need to provide the entire object, right? Like it's pretty common. It's pretty common to have a situation like this where you have your configuration, but you only need to provide some subset of properties. So for example, if I want to configure the thing, then maybe I'll provide a name. But the other properties, I assume that they'll be filled in with their defaults. So this can be, so what I'm about to show you is really useful for situations where you want to make things optional. So what I'm going to do is I'm going to create a situation where I have a type that has my base configuration, but then a type that is my actual config. We'll call it optional, with optional or something. Now what this is going to be is all the keys in our base config, all the keys in base config, and then the associated value with it. Okay, beautiful. But we're going to make them all optional with a question mark. Super sweet. So now what we can do is when we actually say that our configure the thing takes a configuration object, what we're really saying is, hey, we want you to take the configuration object that's optional. And then what's even cooler is we can even provide it with a default. So let's say that we have our default config, which of course is our base config. And this will have our name, and this will have our should do something. True, I suppose. Update after thing. False is the default. How many things? I don't know, 2. Seems like a nice round number. So what we can now do is say, okay, if I don't provide a config, we'll provide the default config using the ES syntax for initializing undefined values, initializing parameters. Okay, cool. Then we can, go ahead and do the thing. So what's nice is now my my compiler isn't yelling at me anymore. Notice if I had done base config, it would say that my configuration object that I'm providing isn't complete. It needs all the rest of these properties. Well, I'm lazy and I don't want to have to do that. I want to only provide the ones that I care about. And there you go. Now we can do that. And of course, on my side, it can then just be like my internal config is going to be the same as my defaults merged with whatever my config is. And then go ahead and do the thing. Pretty cool. So, any questions? I want to kind of use the remaining time for any questions.
I was kind of curious. I have actually used TypeScript in a minimal way.
Mm-hmm.
But any tips you can give me? We don't have a ton of time maybe to do it all, but like running the TypeScript files and more of the configuration side.
Mm-hmm.
I'm tempted to say, show me that test file, but we may not have time for that. I'd rather know more about that later, maybe.
Cool. Yeah. No. Absolutely. It's actually not as crazy as it seems. So let me point out a couple. So I'm glad you asked that because this gives me a chance to kind of point out my file structure here. So let me go ahead and run my clean task, which will just destroy my, there we go, beautiful. Okay, all right, so there are a few really important things here. So the first thing is the tsconfig JSON. There's a lot of commented out here, but this is what's generated when you use the actual TypeScript command line interface to generate one. I like it because you can easily comment things in and out based on what you need. So this basically is the configuration for how you want your code to get compiled. So let's do a quick crash course in what these mean. So to step out for a second, all this is describing is the process of taking your TypeScript files, which are your input files, right? I've got my TS files here. And my tsconfig is simply there to say, I want you to do these things with these TypeScript files and output them to somewhere. Because really, at the end of the day, all the TypeScript compiler is doing is taking TypeScript files that you've written, compiling them into normal JavaScript, and outputting them in a folder somewhere. That's really all that's happening. So there's a lot of stuff here because there's a lot of like settings you can set. But let's I just want to point out some of the really important ones. So the include, this one's very important because this tells the TypeScript compiler where to look for the source files, the input files. So it's convention to use a source folder. You could call that whatever you want, but this has kind of become the convention. Exclude is exactly what it sounds like. It's saying, hey, don't compile anything that matches those file names or patterns. Okay, let's look at some of these compiler options. So target means what version of JavaScript do you want to compile down into? ES5 currently seems to be the standard or convention just based on how widely accepted is by most browsers. So even like old browsers are perfectly fine with ES5. So it gives you a lot of leeway there. Module, this defines what kind of module system you want it to use. Again, CommonJS is conventionally the most common. Okay, this lib folder, I'm going to skip for now. Declaration, I will skip for now. Outdir is very important. This just says, hey, where do you want me to put my output files? So dist has become the convention, but you could name it whatever you want. Doesn't matter. Basically, anything that's in your source files are going to get compiled and moved into this file or folder. I mean, couple other. So those are the main ones. If you're interested in learning more about these, feel free to check the documentation. Really helpful stuff, but it's probably not too necessary to talk about that quite yet. So now I have, mine's a little fancy. I've got several different configuration files here, depending on whether I'm developing or testing. So tsconfig.json is my production compiler config. I've created two other ones that extend that production one, but then I can override things as I see fit for this particular one. So when I'm running this in development mode, I'm going to get my source map so that I can debug, for example. If I'm in test, I'm going to use my I'm extending my dev config file, but then I'm changing my exclude to not include this playground because my tests don't cover that file. So that's an example of how you can kind of use them for different environments. If we look at, so does that help a little bit, Paul?
Yeah, that helps a lot. Thanks.
Yep,
I like
cool.
how I was seeing that example of the multiple environments, stuff I wouldn't have been able to easily see on a simple tutorial. That's good.
Yeah. So to kind of understand, what I'm going to do now is I'm going to run this. So I've created several. I tried to make this as like compact as possible so that anyone that wanted to play with this could easily just get up and running. So I've got several scripts here. So the playground will run just that file. The test will obviously run all the tests. But these builds will basically do the compiling. It won't run any code, but it'll just do the compiling. So that's what I want to show you right now. So as well as some other just helpful things if you want. So let's look what happens when I run my test build script. So it's going to clean out my dist file, and then it's going to compile using TSC. That's the TypeScript node npm package CLI command. So when I run this build command, what we're going to end up with is the compiled files from compiling TypeScript using this particular configuration file. So just so you can anticipate kind of what's going to happen, my test JSON is extending my dev JSON. I'm going to get everything compiled except for my playground. And then I'm going to have these settings. So I should expect a dist folder. I should expect everything in source, of course, except for the playground. That should be what I see. So let's make sure that's what happens. So I'm going to go ahead and run that task. What is it? Test build. All right. See it happen. Okay, cleans it out. Sweet. Okay, look, here's my dist folder. So here's my source. Here's my dist. Check it out. So notice it's got the source map. So I did that on purpose so that I could debug. And it's got my tests. And notice it's JS now. And it looks kind of messy because it's been compiled down. Go ahead.
I'm sorry. I'm really dumb. What is a source map?
Oh, a source map is just a file that points to the source code for what built that file. Okay. So like when you're putting breakpoints in your code, like let's say I wanted to testing some function and I need to put a breakpoint here. Well, in the compiled code, the lines, of course, aren't going to match up perfectly. Like line 50 here is not going to be the same as line 50 in my source code.
Right.
So the source map is there to like reconcile that so that your debugger will actually break at the point in your source code, not in your compiled code.
Awesome answer. I appreciate it.
Yep. So, so this comes with testing, debugging already built in, and you can. There's no magic here. All the configurations are explicit. So please feel free to take a look at the scripts and the configuration files to see how everything's put together. Everything's pretty. Everything's there. There shouldn't be any magic here. Hopefully. Anyways, I'm trying to think if that's, so I did want to go over, I know we're running out of time a little bit, but if you guys are interested, I'd like to at least go over one of these functions that I've put in here to kind of show you TypeScript in action. Does that sound good?
I'm staying a minute more because this is the exact code that makes me not want to code it because it looks like all those brackets and stuff. It's what is this?
Yeah. I get it.
And there is no time limit. As long as you want to talk and people want to stick around, keep going.
All right, great, cool. Yeah, I got nowhere to be. It's COVID, so.
I got to get off soon, but I do want to watch this.
All right, cool. Yeah. So let's take a look at some of these. So let's look at okay, so this one I already showed you guys earlier, the sum function, which I hope is straightforward. It's just an X and a Y that takes two numbers and outputs a number. Okay, let's look at this one though. So this probably looks kind of crazy. So let's see what the hell is going on here. So, okay, add property. Okay, it's a function. So, okay, it's a function. It takes three things, an object, a key, and a value. Okay, so clearly the idea is to take an object and add a key value pair to it. And we're going to return that object with that new property key value, or sorry, that new key value pair. Okay, so let's look at the logic for that first before we worry about the types, because this is using something I haven't talked about yet, which are called generic types, but it's pretty straightforward. So the logic is pretty simple. We take an object, okay, we're going to return an object that is everything that's in that object that's using the spread operator. And we're simply going to add the property and the value to that object, and that's what we get back. And if you look at our tests, I've got a nice little example. So with foobar, add property, I've got this property here, foobar. I expect it to be this, and that's what I get. So does anybody have any questions about the logic of that? I hope that is straightforward enough. So, okay, let's look at how that's being typed. So the thing is here's a case where I've got a very generic function, right? Add property. That means that I can take any object, right? Like I can take anything. There's no way to know what type of object this is going to be, but I know it's going to be something. So that's what this syntax is for. This is for defining runtime types, where you don't, or it's not really runtime types, but it's types that you haven't defined yet until you actually call the function. So until I know what this is, I don't really have any idea. So I'm just going to give it a placeholder called O as for object. V, I also don't know. I don't know what type of value this property is going to have, but I do know that the key is going to be a string, right? Because property keys, or sorry, object keys are always strings. Well, they're also numbers or symbols if you want to get crazy, but you know, they're in most cases they're strings. So essentially what we're doing is we're saying, okay, take an object that's of type O, whatever that may be. We'll find that out later when we actually call the function. So in the test, we know that it's going to be, in this case, that. And then we know that, oh, wrong one. And then we know that the return value of this function is going to be whatever that type is merged with this object. This object is simply an object that is a key that's provided by this guy, which has a value of v, whatever that happens to be. And then we just do our logic in there. There's a few keywords that I haven't talked about yet. Typeof is the way to extract the type from a variable. So that tells you, hey, that's going to be whatever that is. And then this means combine, or it's a union to be more specific. So that's how that works. Yeah, and I realize that it's a few more lines of code, yes. Or at least it's a few more. It actually doesn't add any more lines in this case, but that's a fair amount of characters that it's taken up. But the nice thing is that what it does is it lets you enforce these values. It lets you enforce these types. And one of the things that TypeScript is basically, well, TypeScript has made me a much better programmer because it has forced me to be very, very specific and careful about what data types I'm using. And it forced me to structure and organize my code in a much more organized way. And it made me code with less surprises. Like the bugs that come up they don't surprise me as often. Not to say that they don't surprise me, but usually a problem is much easier to pin down because you can't, in JavaScript, it's so easy to do something like, it's so easy for something like this to happen, where you have some function and you have some object that comes in and you want to go do something with that object. Well, what happens when you're trying to do all this, right? It becomes very difficult if that's null or one of these things in between happens to be null or undefined or whatever. Then you have to kind of dig to see where that value is getting passed because this is a runtime problem. This isn't a compile time. If you had typed your stuff properly, then by the time you'd written this function, you wouldn't be so surprised if you encountered some issues with this nested object. And when you have a code base that's 1,000 files large, this is pretty hard to debug without having types being enforced. So I think when I was working on a really large project in TypeScript is when I really became appreciative of what TypeScript does.
All good stuff, man. Appreciate it.
Yeah. But yeah, you guys have any other questions? I'm happy to answer anything you got.
That was a good short description of generics. I've used them in other languages, but I haven't figured them out here yet. So.
Yeah, generics are I wish I could do a whole other episode on just generics because they're really cool. They're also really advanced. So I didn't want to do it in my intro to TypeScript because I didn't even fully understand generics until I had been playing with this for a couple months. But generics are really cool. But they're so abstract because they're like variables, but for types.
Mm-hmm.
There's a lot of cool stuff you can do with them. Such as, I would invite you guys. I was actually pretty stoked about this. So I rewrote the reduce function. So this is the native JavaScript reduce function that I more or less rewrote as just a plain function. Which basically, if you understand this, then I'd say you pretty much grasp TypeScript for the most part, because I'm using several overloads, generics, union types, optional types. I'm using never. But what's cool about this, and what I was worried about with TypeScript at first was having to write lots and lots and lots of types. Now, when you're defining database schemas and stuff, there's, obviously you're going to be writing lots of interfaces. But for things like this, it's actually not too bad once you do it right. Because this is if you look at the logic of this function, there's not that looks pretty normal, I think. That's just good old fashioned JavaScript, pretty much, except for that. But for the most part, this is all very standard JavaScript. The crazy part is this, and this is where TypeScript is basically so useful. You get to define what your variables are, what they may or may not be, or what they may or may not take, what they return, and yeah. So check this one out and try to wrap your head around it, and I think you'll understand TypeScript after. But that's all I planned for. But if you guys feel free to ask as many questions as you want. I hope that was helpful.
Yeah, that was really good, actually. And if you guys are interested, we can do this again next month and go deeper. I haven't had anybody propose anything else yet.
Yeah, I mean, I'd be happy to do one on generics for sure. So if there's interest there, I would definitely do it.
All right. Well, no questions forthcoming. I'm going to go ahead and stop the recording then and talk some more if anybody wants to.